This is the latest part of my series showing my attempts to build a model 4-column beam engine. The drawing calls for this part of this crank arm on the main crankshaft, calls for this part of the arm anyway to be thinner than the area in the boss. Several ways you could have done it. I could have made the bore at this end larger and then fitted an insert in to create that effect, and actually made this out of thinner metal, but I didn't do that. So the task I'm now faced with, in fact, is to reduce the thickness of this end to something like what the drawing calls for. Years ago I made this, I suppose a fixture plate or something, which fits on the rotary table on the middle. There's the boss, and what you do, if you can get it set up, is to centre whatever you're working on in the middle here, clamp it down by whatever means, and then you can rotate it on the rotary table to machine whatever it is you think you're doing. Slightly speeding up piece of video showing this rotary table machining the end of the crank arm to make it look more round. My filing skills are not great. Nowhere near medal winning, but I'll have to do. I've got fed up trying to machine this, so as far as I'm concerned, that's it. Just a mock-up. I've machined the two bearings, and I'm pleased to say things seem to turn around okay. I haven't bolted the bearings down yet because I'm not too sure exactly where they're going to go. Probably the next thing is to do the beam and sort of make the connecting rod or whatever it's called before I settle on precisely where I'm going to drill that lot down. But yeah, I'm happy with that. Very good. This is the start of a ginormous mistake. This, I think, is the trunnion bearing in which the beam of this beam engine kind of rocks. And I have made a colossal mistake. I was tempted not to own up, say nothing, either scrap the part or I don't know, but my conscience has overcome me and I'm going to own up to what I've done wrong. The distance, this hole is in the wrong place, this bearing is in the wrong place. The distance between this pivot point here and the centre of the pivot for the rocking beam is supposed to be, by this drawing, is supposed to be 1/2 inch. But actually, I don't know how it's happened, but anyway, it's more like 9/16 of an inch. So if I were to unscrew this, the cut line isn't on the centre of this bearing and you would never fit the shaft. So in essence, this hole needs to move in that direction. use the finger, by approximately 1/16 of an inch, dimension to be checked. I have turned, it's brass actually, but anyway, I've turned a piece of brass to a fairly reasonable sliding fit in the incorrectly positioned hole, and the plan, if it is a plan, is to tin that piece of brass, solder it into this part, and then re-drill, re-ream this hole in the correct position, which, as I said, is going to be about 1/16 of an inch or so in that direction, to be checked. This is what I'm on about. It's supposed to be 1/2 inch from there to the centre line of that pivot, and isn't. So I spent a few minutes wondering where in the new workshop I've put all my solder, and surprise, surprise, it's staggering really. It's in a cupboard that says soldering. Blooming heck. Now I've had a further thought, and I can't tell whether it's a good thought or a bad thought, but solder is, soft solder, not the strongest material on the planet. The piece of brass which I tend to plug this hole with has been turned down so that it's a fairly reasonable sliding fit, i.e. it's got a little bit of clearance with what I thought was going to be solder, but I'm wondering whether to use Loctite retaining compound to fit this into that. I mean, this parting surface is not going to get hot, so there's no fear of overheating the Loctite, I don't think. And I suppose the reality is, if I use the Loctite, it avoids heating this whole assembly up, which I didn't really want to do. And I suppose if it doesn't work, I still have the option of either scrapping the lot or cleaning it up and reverting to the original soldering plan. So I'm going to try the Loctite approach. Right, I've corrected the drillings through these two trunnion bearings as described, and the Loctite idea worked, I'm pleased to say, so I didn't have to do any heating up and soldering. That seems to have worked quite well. And this is another mock-up with I think that's the beam trunnion, and I think this bit's something to do with valve gear. I'm not quite sure, I haven't looked at the drawing yet. Anyway, everything's just placed there, nothing much bolted down, and it all seems to work. Philosophically speaking, I suppose the message is that when you make a mess like I did with these drillings, instead of just throwing the part away, which is very tempting, the challenge is how you overcome the problem that you've created, and it's really all about that. Happens to me in the workshop all the time. Never mind. The trunnion bearings are fixed to the entablature, and by eye really, but as best I can judge, everything is parallel to everything that it ought to be, hopefully. So everything, once it's on the beam engine, should be a-okay, I hope. Time will tell. The beam and its pivot are done, and seems to look correct. I have to make oilers for the various bearings, but there's a few of those around this engine, including down here, so I'll make some oil cups when I'm in a good mood, because they take quite a long time. But anyway, yeah, seems alright as far as I can judge. And it sort of lines up at the end to where the piston's going to be, which will connect to all the valve linkage, of course, the parallel motion gear. But we're kind of there. So yeah, at this junction I'm relatively happy, I suppose. I've made some oil cups for some of the bearings, and the next job is to try and make the connecting rod, or whatever it's called. I've drilled, hopefully in the right place, who knows, some of the primary holes that seem to be on the drawing, and I guess the next step is to sort of form the profiles. I'll have to take a look at the drawing. The drawing calls for a bit of cosmetic turning at each end of the connecting rod. Not the sort of thing I like doing, and quite a faff to do, but I suppose I'd better have a go. I've centre popped each end of the connecting rod, put a dead centre in the headstock to then centre on the pop that I've put at this end, and I've got a rotating centre at the tailstock, and then fairly lightly gripped this end of the connecting rod in a 4-jaw to provide some grip to turn the flipping thing, in an effort to profile these two parts to look something like what the drawing says. I think that's all I can be bothered with. Bit of turning at each end, just cosmetic, no real measurements. Only one incident with things flying out the 4-jaw chuck, but we don't talk about that. Pretend it never happened. So if I've understood things correctly, I have to now remove the chucking pieces at each end of this rod in order to finalise and profile the relevant parts. I think I'm going to do that by just hacksawing off the redundant pieces. I mean, I could do it other ways, but just hacksaw seems as easy as any. As long as I leave a bit of metal to clean up, it'll be fine, I hope. Dimensions aren't finished at each end, but getting there, I hope. I mean, these slots should be exactly to half of the diameter of whatever that hole is for, and ditto here should be exactly half the diameter of the what was the hole. So they're a little bit oversized at the moment, a little bit more to come off. But I'm not going to do that until I'm more certain of where I'm going. Next step is to cut out along here to make the kind of U shape, which is this bit here. These are the top end bearing shells, still to be unsoldered because they're in two halves, but turned to finish size and reamed 3/16 in the middle there, which is what the drawing calls for. So let us hope it's all correct. I think I mentioned this before. In my view, there is an error on this drawing. The top of the fork, which is the sort of connecting rod, and I've machined all this up, shows a U-shaped machining 3/16 in diameter, but the bearing cap, which is supposed to fit in that, in my judgment, actually has a diameter of 5/16. The 3/16 refers to the bore of the bearing, not its kind of internal or outside diameter, if you follow me. So the sort of slot, the U-shaped slot that I'd carefully machined into this, has got to be increased from 3/16 to 5/16. So I've put a 5/16 cutter in a collet in the mill, and the plan is to run that up and open this 3/16 kind of U-shaped affair to 5/16. But of course, if I'm to maintain the centre line of this fairly accurately, which it should be really, the 5/16 cutter needs to machine into this U a little deeper. Now the difference between 5/16 and 3/16 is 0.125, an eighth of an inch, and if you halve that you get to 0.0625 thou, and in my judgment, when I get to the bottom of this this U here, the travel needs to be moved along by 0.0625, which should then bring the centre line of the 5/16 U to the same centre line, which was carefully marked out as the original and incorrect 3/16 hole. So that's what I'm going to do. Well, does that look right? Who knows? Let's hope so. Well, not brilliant. Might need to remake these bearings because there's a bit too much of an overhang this side. Cosmetically, I don't think it makes any difference, but at least I've got the bones of the dimensions sorted out, and the bearing caps work. I'll see if I get enthusiastic to remake this. I haven't made the retaining straps yet, of course, but that's how it's supposed to go with the split bearings each side. The shaft itself is a light press fit in the beam, and the shaft is not intended to and doesn't rotate because it's pressed in. The two end shells are the bearings. Of course, the whole kerfuffle of split bearing caps and straps and whatnot has got to be repeated at the bottom end. I think I'll save that for another day. It won't win any prizes, but I think it'll work. This video is getting a bit long really, so I'm going to call it a day on this one here. Thank you very much for watching, and if it's of interest, watch out for the next part. Many thanks.